Hi, my name is Raghuvanshi. I have pursued master's degree in thermal engineering from JNTU Kakinada. Now I am working as a MEP design engineer. I have 7 years of experience as a gate trainer and worked in various institutions like Vani Institute, IS Gate Academy, Gate Masters throughout India. I deal with thermal and its applications and heat transfer subject. In recent times, I observed that there is a digitalization of lifestyle with the help of 4.0 technologies. So, the online education platform are developing unprecedentedly. So, majority of students are getting accustomed to the online education system. This kind of education system is proven to be more effective as it provides proper conceptual clarity to the students with the help of virtual examples. And also the live interaction between student and educator helps in clarifying the doubts easily. Unacademy is one such a platform which creates a revolution in online education system. Majority of students getting benefited through it. By being a part of Unacademy, I would get a great opportunity to share my knowledge. And I have a scope to teach large number of students. Under my guidance, many of my students have qualified the GATE exam and some of them are working in public sector units. My method of teaching is different from others. I teach the subject from very basic level. I make the students to understand the concepts with my industrial experience and with practical examples. In my class, I provide guidance to crack the GATE exam very easily. Now I am going to explain a beautiful concept. Why the specific heat at constant pressure is greater than specific heat at constant volume. This is very important interview question. Now I will explain with a beautiful practical example. Now listen carefully. Consider two cases. The piston cylinder arrangement. In first case of piston cylinder arrangement, the piston is freely movable. In second case, the piston is fixed. This cannot move in upward or downward direction. Alright, now listen carefully, my dear students. We know that what is meant by specific heat? It is the ability of a medium to absorb or store the energy. Right? Now listen carefully. By supplying heat to the system, here what is our system? Air is our thermodynamic system in both cases. Hope you got it my point. Now by supplying heat in this first case, what happens? The thermodynamic system, which is air, absorbs heat. The internal energy of air increases so that its temperature also increases. Now what happened to the thermodynamic system? By absorbing heat, slowly it expands. When the gas, the air is expanding, what happened? This piston moves in upward direction. When the piston moves in upward direction, what happens? The inside pressure and outside pressure is constant. Now can I say this first case is constant pressure process. Hope you understood. Now we are supplying heat at constant pressure process. Now I am indicating heat supplied at constant pressure. Now coming to the second case, listen carefully. Here the piston is fixed. Now slowly add heat to the thermodynamic system. What happened? The air absorbs heat. Internal energy increases and temperature also increases. Slowly the air wants to expand. Yes. What happened? Here the piston is fixed. So the air cannot expand. At this point, the pressure inside increases. And see carefully here. In second case, after supplying it, after some time, the volume of thermodynamic system is constant. There is no change in volume. But in first case, when the piston is moving in upward direction, the volume of thermodynamic system changes. But in second case, the volume is constant. Therefore, the second case is constant volume process. So we can say that heat is supplying at a constant volume process. The first case is constant pressure process. Now to understand this concept, I am going to take two conditions. What are those? Delta T in first case is equal to delta T in second case. This is the first condition. And mass of air or gas is same in both cases. Now please concentrate here. Now listen carefully. From first law of thermodynamics, what is the first law of thermodynamics? We know that dq is equal to du plus dw. Now for time being, I am simplifying this as q is equal to u plus w. Alright? Now listen carefully, my dear students. In first case, we know that q is equal to u plus w. Now for example, I am taking the heat supplied to the first case, for example, just taking as 10 units. Right? Now in this 10 units, 8 units is utilized by the thermodynamic system, which is air. The 8 units is used to raise the internal energy of the air, and remaining 2 units is used to raise the piston. Hope you understood. Now come here. In second case, we know that first of all q is equal to u plus w. Alright. Now listen carefully. This is very important. In this case, by supplying heat to the system, the total heat, whatever the amount of heat we have supplied to the system, that is totally utilized by the air to increase the internal energy. Yes or no? In the second case, the total amount of heat supplied to the system is only utilized to raise the internal energy. That's it. There is no work done on piston because piston is fixed. Hope you got my point. So there is no work done in second case. Clear? Now whatever the amount of heat supplied, that should be only utilized to raise the internal energy. So can I say q is equal to u? What I said, listen carefully. The condition, we know that what is Joule's law? Internal energy is equal to function of temperature. As we assumed delta T1 is equal to delta T2, the internal energy in first case must and should be equal to in second case. So what is the U value we have taken in first case? That is, for example, we have taken 8 units. So here the internal energy is 8 units. So the amount of heat supplied for the second case is equal to 8 units. So I am writing this as heat supplied at constant volume process is equal to 8. Now listen carefully. Now you have to say which heat supplied is more, in first case or second case. For same mass, for same rise in temperature, therefore the heat supplied at constant pressure is greater than heat supplied at constant volume. We know the formula. Q is equal to mc delta T. Yes. Now can I write in place of QP m specific heat at constant pressure Cp delta T1 is greater than QV mass CV suffix V specific heat at constant volume process and delta T2. Now we know that we have assumed mass is same in both cases and delta T is also same. That's it. Therefore, specific heat at constant pressure is greater than specific heat at constant volume. That is the beauty of thermal subject. Hope you understood. If you say like this in interviews, definitely you will select in that interview. Hope you understood. Thank you for watching.